Hello Creality Ender 3 S1 owners. I'm sitting next to my Ender 3 S1, and if you are here watching this video, it's likely because you have the same problem so many other S1 owners have. Really bad pronounced layer lines or ringing. I have been hard at work coming up with solutions to this problem, and today I present to you a list of potential fixes to improve the print quality, specifically the visible layer lines or ringing in your prints on the Ender 3 S1 printer. Many of the things I will cover briefly. You can use that as a launching point to further investigate watching more detailed video and written resources on that specific issue. That said, we have a lot to cover, so let's get started. The first thing to cover is the reason you're here. We are specifically looking to tackle Ender 3 S1 printers that print like this. Number 1, checking for looseness in your hot end. Your hot end should be firm on the rails. When you grab this, you should not be able to shake it or jimmy it or rock it back and forth or forward and back. It should be firm, and the whole printer should kind of move along with it as you try to shake it. If you can grab this and rock it this way and it's moving, that's a problem and we need to fix it. To do that, you want to get behind your printer and look at the eccentric nut underneath this wheel right here. I will demonstrate right now on a dummy unit. Take note of this nut right here. That is called an eccentric nut. That nut moves this wheel in or out of the rail to increase or decrease pressure against these wheels. By pushing or pulling against this rail, these wheels will push or pull against the opposite rail, making this entire contraption looser or tighter. You can tighten this eccentric nut to make it more stable. To do that, all you're going to do is grab this little wrench that came with it, put it on the nut, and turn it. After turning it, you should see that there is no wobble whatsoever. If when you turn it, it actually wobbles more, just turn it the other direction until it doesn't wobble. Once you've tightened this up, this should move smoothly, and there should be no movement if you try to shake it. Looseness of your print bed. When you grab the bed, you should be able to pull up and down without any movement on the bed at all. It should be firm. The whole printer, again, should feel like it wants to move. Should this bed physically wobble up and down when you put pressure on it, the eccentric nuts underneath this bed are too loose and need to be tightened. Have a look under your bed and you'll discover 2 eccentric nuts. If those are loose, there's not enough pressure against the rail and your bed will wiggle. Look in your kit wrench you have, came with your printer, slide it over the eccentric nut and turn it. See the difference? No more wiggle. Once you've adjusted those eccentric nuts, the bed should be solid and you should not be able to move it up and down by pushing and pulling on the bed. There are 2 belts we're going to look at. The first one is the belt right here. The next one is the belt right here. Again, there are much more in-depth videos on how to set the tension on these belts. Some of them even get into pretty scientific attempts to explain the proper tension, but I simply want you to feel them. If they're loose and floppy, they're too loose. If they're really tight and feel like a guitar string, they're too tight. But I'd rather it be a little too tight than a little too loose. Grab this adjustment knob and turn it. If it feels really loose, chances are your belt's a little loose and can probably handle a little additional tightness. The bottom line is that we want the gear to move in sync with the belt. We want there to be no delay or slipping whatsoever. When that gear and belt move, we want them to move as one. So if you feel this is too loose and that may not be happening, then you need to make it a little bit tighter. You can experiment by printing and making an adjustment, letting a few layers go and making an adjustment. When you feel confident that the tightness is okay, leave it be. If you start to have doubts, you can always back off a little bit. But the idea is for it to be firm enough that it feels springy, but not too loose, not too tight, but definitely not too loose. The same applies to this belt right here. This is an important belt because this belt pulls your hot end back and forth. You can get in there and push on it. You see it's a little springy, You get underneath and you feel that's a little springy. There's tension, almost like a tightrope. It's not sagging or drooping, and this doesn't feel soft and squishy. If it does, you just grab this knob and just tighten it a little bit. Feel it. Underneath, feel it. Does it feel like it has some good tension? That's great, leave it be. If it feels loose, like it might be slipping on that gear, tighten it a little bit. Again, you can print, you can watch it move, and you can make adjustments every few layers to see if it's making any difference. Find a good tension that you're confident is working properly and isn't contributing to your problem. This is an important one, the wheels and eccentrics on your Z. We want things moving together and easily and smoothly without interruption. Your hot end hitches a ride on this rail. This rail hitches a ride on these rails using this bracket with wheels on each side. These wheels on the side here and the two matching wheels over here that are harder to see are tightened by an eccentric nut hidden behind this wheel on both sides. This eccentric nut controls the tension between these wheels and this rail. What I want you to do is take your fingers and pinch this wheel. Can you turn it? Is it easy? Is it hard? Do you feel like it's in the groove of this rail? Do the same down here. Is it looser? Is it tighter? Does it feel the same? Can you move it? I want you to be able to take your fingers and move both of these wheels with reasonable effort. Not too loose, not too tight, but most importantly, I want them to feel the same. Now, focus on the inside here. Here is the eccentric nut. Tightening this nut will put pressure against the rail by this wheel. Putting more pressure against this rail will pull this whole unit inward, putting more pressure against the rail with these two tires, making this entire unit grip tighter against this rail. Loosening this eccentric nut will create less pressure, easing the pressure against the rail of the opposing wheels and this wheel as well, making this move smoother and more easily up and down this rail. So here's what you're looking for. If these wheels spin freely and easily, we want to tighten this eccentric. If these wheels spin super tight and are really hard to turn, you want to loosen this wheel. We're going to adjust the tension so that they're just tight enough that you can turn them with your fingers, but not easily. However, if one is looser than the other, we need to adjust this mount before we finish tightening the eccentric nut. This is an often overlooked step. You are going to loosen this nut right here, and you are going to loosen this nut right here. The idea behind loosening these screws is that it allows this plate to have just a little bit of wiggle room. So if the plate's sitting kind of cockeyed and one wheel is making good contact and one wheel isn't, once you loosen it, you can straighten it out, tighten the eccentric, tighten the screws, and then they're good. And then you can finish tightening to complete the job. I then want you to slip your number 10 over the eccentric nut and tighten this eccentric nut just a little bit. If you turn it and things feel looser, don't panic, just turn it the other way. Now that you've done that, recheck your wheels. Do they feel like they're making more even contact with the rail? If they do, snug up these two bolts and feel them again. Now that both tires are making even contact with this rail, the adjustments you make here will make equal adjustments here. So if they're making equal contact with this rail, when you tighten it, they'll make equally tighter contact with this rail. Adjust it till they both feel firm but movable with your fingers. Unlike single Z machines such as the Ender 3 Max, where having these wheels a little looser is actually better, you can get away with a little bit snugger on these because they have their own stepper motor. And you don't have to worry as much about this side sagging or drooping. Now that we've done that, push the hot end over and check the other side. You'll notice this side has the same wheels, but they're much harder to check because of all this equipment in close proximity to them. However, you can get your fingers on and just feel, make sure they feel consistent. Make sure they're not too loose, not too tight. Most important, I want them to feel consistent and not too loose. If they feel consistent but too loose, again, all you need to do is adjust the eccentric. If they feel imbalanced, where one is loose, one is tight, then you're going to do the same thing you did on the other side. Loosen this here, tighten the eccentric, tighten this here. Then, once they feel equal, you can loosen or tighten just using the eccentric. For example, if they feel pretty equal but a little loose, just get this wrench on your eccentric, give it a little tight, and feel it. If it gets too tight, give it a little looser and feel it. Next up, your stepper motor and the Z-rod and the Z-rod coupler attached to them. So we've got two stepper motors right here and right here. They're both virtually identical, so we're gonna have a look just at one of them. So here's our stepper motor. What I want you to do is grab it and abuse it. Shake it, pull it, push it, wiggle it. Does it give? Does it move? Does it tilt? Does it click? Does it vibrate? If it does, you need to snug everything up until it doesn't. If it already doesn't, you're good to go and you can move on. From there, I want you to have a look at the coupler right here. I want you to take both of these, make sure they're snug. If they're not, pop a tool in it and snug it up. Then we are going to move up to these guys right here. There's quite a bit of debate on these. Whether or not they should be replaced with plastic ones, whether or not they should be replaced with anti-backlash nuts, how loose and how tight they should be. But for now, we are going to keep them stock. I'm not going to suggest a replacement. And we're just going to look at how yours are installed. When you grab this, I don't want it to be wiggling around super loose. However, I also don't want it to be super tight. Mine happen to be pretty snug, maybe snugger than they should be. But I have really good smooth movement. I don't feel any binding at all, so I'm not worrying as much about them. However, if you drop a tool in and you can shake and shimmy them around, I want you to snug these up a little bit. If they're super tight, you might want to back them up just a tiny bit. Keep it equal on both sides. But I don't want it super tight, and more importantly, I don't want it super loose. Check them on both sides, make sure they're firm but not super tight, and make sure they're not wiggling and jiggling around. On the other side of your machine, you're going to have another pair. You're going to find them hiding behind your cable right there. Same thing, you can drop a tool, make sure they're not too tight, make sure they're not too loose. If they're shimmying and shaking around, snug them up a little bit. Not even snug, just enough that they're not shimmying and shaking around like crazy. Some people will say that side to side movement is okay, but up and down is not okay. Mine actually have no movement and it's working out, so you can use your judgment, but the idea is if this is too loose, this carriage is not going to react properly to micro movements up and down. So don't let it be too loose, make sure it's firm enough. Next up is a quick peek at the side of your Sprite extruder. Unlike Bowden tube setups, the tensioner on the extruder is much less obvious on the Sprite direct drive extruder. It's right here. Now on a Bowden setup, the extruder is a standalone unit outside of the hot end, and you can see the tensioner and the spring and the pressure being put on it. But it's not as easy with the spray. You can't quite tell. Or can you? Put your thumb right here on this lever and push it. Does it feel really loose or is it really stiff? Congratulations, that's the tension on your tensioner. If it's really loose, grab your tool, stick it in there, and give it a little bit of a turn and feel it. If it's really tight, stick it in there and pull it back a little bit. Feel it. Don't make large adjustments. If you screw this up bad and something comes apart, you're taking this whole thing apart. So make small adjustments. Make it so this feels nice and firm, but not too firm and not too loose. And there you have it. You've adjusted the tensioner on your Sprite extruder. Too tight will eat up the filament. Too loose will eat up the filament. You need your porridge just right. Fortunately, there's leniency. I have no specific guidance in how to set it, but if you feel it's fairly firm, that should be good enough. And unless you notice a specific problem where it feels way too loose or way too tight, or there's damage to your filament, or it sounds like the filament is slipping on the gears, I would refrain from making any further adjustments to the tensioner screw. Next up, your memory card. That's right. Spending boat tons of money and dumpsters full of time on 3D printing, and then trusting your print jobs to cheap, no-name, slow, outdated, antiquated technology cards is silly. Use a high-speed, current technology, name brand, memory card you can trust, 32 gigabyte or less, formatted in FAT32 for the best chance in having printing performance that isn't affected by read and write errors or performance deficiencies in your crappy memory card. I use SanDisk High Performance U3 32 gigabyte micro SD cards, and I simply stick them in an adapter and use them in all my machines. I will link to this exact card in the description. Next up, consider looking into your firmware and updating your firmware. I'm not a huge fan of the stock firmware. I use professional firmware. There are a few options on the internet. I will leave links in the description, and I strongly consider you look into them and upgrade to one of them. Which brings us to the next item on our list, PID tuning. Look into your printer's firmware and how to do PID tuning. If your firmware supports auto PID tuning, run that. On the professional firmware, you just go to Advanced, Bed PID Settings, and Bed PID. It will automatically do a PID tuning on your bed. If you have that function, I suggest doing it. If you don't, look into how to do it manually or upgrade your firmware so you can gain the ability to auto PID tune your machine. Next up, E-steps. Yeah, I'm sure you've been told every time you stub your toe that the solution is to calibrate your E-steps. But if you're having ugly layer lines and ringing issues, one thing I would definitely get out of the way is E-steps. There are lots of resources online to teach you how to do your E-steps, and I will likely have a video to teach you that exact thing by the time you watch this video. And there you have it, a laundry list of things you can physically check to work on the bad visible layer lines or ringing in your Ender 3 S1 printer. Now we're going to take a quick look at some of the things you can change in your slicer profile to help with that as well. Here we are in Cura, and we're looking at a simple Z-Wobble test. This is a great print to check for layer lines and ringing. It's also a great print because it allows time to make changes during the print without having to start over. For example, you can make changes to your belt tension and watch it print to see any particular changes. You can make changes to your print speed and watch it print to see any particular changes. You can make changes to your print temperature and watch it print to see any particular changes. This can be super helpful while troubleshooting different issues. We are going to use this model to test the results of our efforts to eliminate layer lines. I am in the default Cura Ender 3 S1 profile. There are two specific settings we're going to look at, travel speed and print acceleration. If you don't have those settings showing, they are hidden by default. You will simply click on Preferences, Cura, Settings, and type right here, Travel. And you will see travel speed and initial layer speed. If they're unchecked, you'll notice they disappear on the right side of your options here. If they are checked, you'll notice they appear on the right side of your options here. While we are here, we are also going to check travel acceleration, and you'll notice that appears right here as well. We are then going to type in print acceleration. If print acceleration was not showing up on this side of the screen, it would be unchecked here. And all you would need to do is check it. And now you'll see you have print acceleration. You can close this out and those options will stay visible. Many people suggest that because the Sprite extruder is heavier as a direct drive extruder than non-direct drive extruders, it can benefit from a slower travel speed. Some recommend as low as 110. I'm going to recommend as low as 110. A dramatic change like this will make it more clear to you if this change actually made a difference or not. We are then going to go down and reduce our print acceleration by 50 and our travel acceleration by 200. Using these slower speeds, you will then slice this model and run a test print to see if they've made a noticeable difference in the quality of your print. However, before you do that, I'd like you to go up here and set your Z seam position. This is another thing you may have to turn on in Preferences, Cura, Settings, type in Z seam, and check Z seam alignment and Z seam position. Once they're turned on, I want you to choose User Specified, then Front or Back. This will position your Z seam in a straight line. This will allow for a much easier and smoother print to review. The final thing I'm going to say is please don't run your test print at ludicrous speed. No 100 millimeters a second, no 80 millimeters a second. I want you running this test at somewhere between 35 and 50 tops. When you're having issues and you're troubleshooting, success and quality are the only priority. Speed is not a priority. Success and quality. Once you have success and quality, then I'll be willing to discuss speed. So for now, test print at 50 or lower. Slice the model, give it a test. Hopefully, after exhausting this list, you've been able to identify and resolve some problem errors in your S1 printer. Doing so should reduce or eliminate the ugly layer line problem that so many people have with the S1 printer. If you've had success with these methods, I'd love to hear about it. You're on the 3D Rundown YouTube channel. I'm Greg Adventure, your instructor at 3drundown.com, and making the Ender 3 S1 printer print like this was today's adventure.